So good morning, everyone. My name is Nancy Faget. I'm with the Army Research Laboratory Library in Adelphi, Maryland. And I started looking at supporting Dr. Stephen Lee in the International Strategy Group, trying to determine what sorts of research would be of interest around the globe, and trying to find ways to make our PMs and folks in the ITCs aware of what was happening so that we could, in fact, do that sort of outreach. So with the help of Dr. Beachkofski and lots of other great folks, we had an event at the Library of Congress March the 6th. You can see it's a cast of thousands that were part of this particular presentation. We had folks from academia, folks from the federal government, as well as folks from different companies participating in the event. And we learned about very interesting things from IARPA. NIH is using different bibliometric indicators to help predict highly cited papers and then using that for the PALM process. There's SciCast, which is an IARPA-funded project out of George Mason, used for crowdsourcing predictions, and lots of different things that were mentioned. We also had Dr. Para finishing up the day, trying to ask us questions about what it is that we in fact should be doing, what questions we should be asking. And I understand that Rick is on the phone with us today, so please chime in as you hear these things. So it was our good fortune to have Dr. Beachkofski participate and have his staff help us sort of organize the event. Dr. Beachkofski is the director of the Office of Technical Intelligence within the Office of the Assistant Secretary of Defense for Research and Engineering. He has a vast amount of responsibilities, including coordinating intel support for research and engineering efforts and identifying emerging and disrupting technologies. He has a lot of background with the Air Force, in fact served as a research engineer himself, and he's very well educated with an MBA from MIT, a master's from Georgia Tech, and PhD from Wright State. It's our pleasure to welcome Dr. Beachkofski today. And I'd like to bring up your slides so that you sort of reprise your presentation from the Library of Congress.
Great. Well, thank you very much. So today I want to go over some of our use of technical data for being able to look at emerging technology issues and future trend analysis that we use to inform the entire research and engineering portfolio in the Office of the Secretary of Defense. I think the way I go is it would be interesting if there are questions anywhere along. If you'd raise your hand, I can call on you there. Otherwise, we can also save questions to the end. Either way is fine with me. So in our Office of Technical Intelligence, our job is to help give the global context of technology for the research and engineering community in the Department of Defense. So we look at the way the world is today, the way the world is going to be in the future from a technology perspective, and then try and provide that technical context for what do those technologies mean to the business practices of the DoD. So, for example, what would a given technology mean for our logistics infrastructure? Potentially, what does it mean for the way we conduct operations or the like? So this again, we look at where we are today, but then really more importantly is where are we going to go in the future, because a lot of our development timelines, if you look at system acquisition processes, are 20 years or longer in length. So you really need to understand tomorrow, because if you build a system using only today's information, it's going to be out of date by the time it actually reaches the field. So one of the ways we do this is providing threat information. So what are other countries doing? Uh, what are other places in the U.S. doing? And what does the technology mean? So we actually work with the intelligence community quite a bit to understand what foreign system development looks like. But this is more on today, and I think the focus of our talk is going to be on how do we predict what happens in the future.
Brian,
Yes.
could you speak up just a little bit and then also make sure that you've clicked to sync your slides in the bottom right?
Oh, absolutely. Let me turn my microphone volume up. Hopefully that helps a little bit.
It does,
And
in
then let
fact,
me do.
and now we're synced. Thank you.
Okay, and now I'll sync. Okay, so like I was saying, the the threat estimation is really involvement with the intelligence community, but what we care more about is what we look towards in the future. So some of the products we have, looking at these are both current threats, but actually looking more into emerging, so things that are just nascent right now. On the left, you can see a few reports there that we had the Jasons, who are a group of academics, including those with a few Nobel laureates on our team, that look at technology issues from a national security perspective and write reports on the implications or the feasibility of certain technologies based on the inherent physics in the problem. In the middle, you can see our S&T News Bulletin. It's a weekly publication, and at the end, you'll see there's links to it. It's open for anyone to subscribe to. And if what this does is it's a pull from RSS feeds and other sources that we have our own on-staff technical librarian review and either use the abstracts or modify the abstracts to make more sense for our typical user, and have about 5 pages worth of interesting news articles that came out that week for S&T that may have defense implications. And then, in addition to the weekly bulletin, we have a quarterly in-depth where we actually get technical articles and technical journal publications on a given topic. So some topics we've had in the past has been cybersecurity. We've looked at photonics in some others. But every quarter we come out with an in-depth that goes beyond the press release and gets into the technical articles themselves. All right. And on the right is our Intel Needs Plan, which is a document that we provide back to the intelligence community based on the things that we've seen in those other documents and other activities to determine what we would like to know more about if the intelligence community sees something happening. So looking to more directly into the future, seeing emerging technologies, we have a program called the Technology Watch and Horizon Scanning Effort, which is looking at two aspects of forecasting. One is Tech Watch, where we have an identified technology that we want to track how exactly the development is going and what the development pace is going to be. So that is one where we know what we're looking for before we start doing the investigation. The second is horizon scanning, where we don't know what is coming, but this is really to eliminate surprise. So we just look at the entire horizon, and as things start to develop, we then switch over into a Tech Watch mode. So this is really trying to find what the next thing is going to be that people aren't aware of as much today. And this is where our bibliometric tools and our pattern analysis tools really help out. we're going to get a little bit more into what exactly, how do we evaluate a technology for emergence, and what factors do we look at in emergence. Um, we evaluate three factors. What is the technology? Is it real? Is it feasible? Is it, how far along development is it? And are there physics or other aspects of it that are barriers to it becoming real? The second one we look at is motivation. Do people actually want to use a given technology? So this comes through sentiment analysis. Social media is actually pretty good for it, where you can see if people think a technology is cool, they're probably more likely to use it. And then the third area we look at is what is the threat. So are other people, are other actors thinking of using it? And then does it actually, do we see activities that would make sure or indicate that someone else wants to use it in a nefarious means? So how do we respond to different factors here? The first is, so if let's look at risk management. If the technology is feasible and the threat is there, where it could be harmful to the U.S., but it doesn't look like anybody's motivated to use it, we're going to use risk management and really key on those indicators that if we see that people start becoming motivated to use it, that's an issue. However, if people are motivated to use it and it could be a threat, but we don't think it's technically feasible, we would be more likely to engage our policy partners and try and create regime controls that would prevent it from being used. So you could see, for example, this is what happened many years ago when space was first being exploited, and policy led the space initiative to keep the militarization of space, where it wasn't technologically feasible at the time, but it would have been a major threat, so we move into a policy response. The third is, if the technology is there and people want to use it, but it doesn't pose a threat right now, this would be a potential surprise because it doesn't look like it's being used, but it could be at any time because it's feasible and people want to use it. So the middle is really the real concern, and if we see something where it's real, people want to use it, and it would pose a challenge to the U.S., we really find that as a great motivation to get many of our partners involved in coming up with what a right response to a technology would be. So we have different tools that look at these different aspects of technology evaluation. The first being the IC evaluates the threats in a very traditional way, and you have analysts that look and review data and come up with an assessment of what the threat space would be like. From the technology's perspective, we actually have a prototype system that's being deployed now that does bibliometric analysis, that does patent data. We've worked with Recorded Futures to look at open source and press publication of technology predictions of where things are going in the future. So a lot of press reports will say, you know, in the next 20 years we'll see that this will become a big thing. So you can actually pull out temporal data from text analytics. And then motivation, there's quite a growing field in sentiment analysis and social media understanding. So we can do that, and a growing area, one that it looks like the phone doesn't work. Are people still hearing me on the line on the IP?
Yes, but hold on just a second. I want to check and see what's happening with the phone. Bup, bup.
Okay, so it looks like it may only be partial.
So one of the things I would heartily suggest, and we are trying to hook the phone back up again, is that someone purchase access to DCO with integrated telephony at some point, so that in fact we can reach out via multiple avenues.
Okay. Should I push on, or is the fix going to be here pretty soon?
I would go ahead and push on, just so that we keep on time.
Very good. A growing area that we feel is going to be important is in financial analysis. So where is investment being made? Because everyone always says follow the money, and really in technology there are very few people that do analysis of where investments are being made. The other thing that you always hear is a vision without resources is a dream. So again, following the money in tech development does point to where people think the technology is more likely to become real. So when we started our Tech Watch and Horizon Scanning program, there are a few different approaches that we evaluated. One is a manual perspective. So this would be looking at tech forecasting. How do people do it? This is like the experts in a field will say we think this is a trend and this is where it's going to go. We sponsored a study that looked at is there a way to analyze predictions that were made and then validate whether or not they were accurate. So we'll look at that in a second, the results of that study. But basically, it looked like manual methods that rely on analysts are less predictive than automated methods like bibliometric or pattern analysis, which is why we have sort of this focus on data-driven models. The semi-automated TechWatch Horizon Scanning, this is the one that we're trying to develop here, looking at what is the way we can apply tools. Do we have an understanding of the basic causal influences of technology emergence? So if you have a model of what causes technologies to emerge, instead of having to look at all data sources for your analysis, you can really focus on just those indicators that are highly predictive of emergence, which makes it much easier to do the analysis and much easier to look at more technologies. And then finally, we want to do assessments of how things are going, understand where things are emerging, but also where we aren't looking, that we may be able to focus some attention to make sure we don't miss anything and get surprised in the end. So the baseline study we did, which was to evaluate different methods of prediction and determine whether or not the predictions were accurate. So we looked at Tory Group as the group that actually performed the analysis. It was sponsored from our office. And they looked at different sets of predictions. So you can see the pie chart shows the number and types of predictions that were made. By far the most popular is expert sourcing. But unfortunately, in the table, it shows that expert sourcing is only 32% accurate from forecasted events to those events actually happening. What was the most effective was the quantitative trend analysis. So We think that part of the reason is um, subject matter experts are very good at are very good at understanding the world as it is today. However, the cognitive biases that are put in place by having a lot of information about the world today makes it so that your view of the future actually is more like today, and you overlook because you have a positive bias. You tend to overlook some of the hurdles, and forecasters will then tend to err conservatively, um, and say things will take longer because they're too focused on the technical challenges that they've been working in the field. So they overweight the challenges and underweight the actual potential of a technology. So this is why our approach is to is to focus more on an analytical method and using analytical models and data-driven techniques, because those have proven to be the most accurate when forecasting events. One of the issues we have when wanting to use a data-driven model is there isn't exactly a clear understanding of what drives emergence. When I was talking before about this theory of emergence, it's not clear what drives it. So unlike macroeconomic models where there's a theory of economic emergence and how nations can catch up and participate in economic development, there isn't a parallel to microeconomics for a given technology. So because we lack that, we really want to have this augmented, semi-automated approach where we use humans for doing what humans are good at. They do very well at qualitative analysis, but let computers and algorithms do what they're very good at, which are the quantitative methods, and then bring those together and let people synthesize both the human elements and the data. I like to say that computers are good at going through huge amounts of data very quickly in a way that no person could, and they're very good at identifying things that are anomalous or unusual or interesting, but they're less good at saying why it was anomalous or why the data was interesting. But if you can get a human, especially an expert in the area, to look at that, they can come up with those reasons why much better than could a computer method. So what we want to get to is this quantitatively based, data-enabled capability to look at emerging technologies. The output we want to have for emerging technologies and the decisions we're trying to prioritize are, one, what are those opportunities for investment so we can maintain our advantage? What is the prioritization schema? How do we do these deep dive assessments to evaluate whether or not a technology has special DoD relevance, and then what other countries would be doing. So that the real key is we use this TechWatch Horizon Scanning System to queue up our analytical effort, where we evaluate the impact of DoD. We do that through this assessment method that comes out. So you can see here we go from data to the emergence method, which is unifying theory, through data science, and come out to this product. So the product would be an evaluation of a given technology that has data support, analytical support, to justify why we think this area is important. So by bringing the automation and the experts together, we can get to this technical assessment more quickly and identify emerging technologies more quickly, and understand where the DoD has to react and get out in front of some of the revolutionary technology moves. So when we get to the assessment, we really try and understand what does it mean for DoD. With a lot of technologies, the use cases are not for DoD. There was a time when we talked about defense and space spin-offs into the commercial world, but I think the times are really changing, and we're seeing more spin-ins to the DoD from developments that are happening outside in the commercial space. So you may see developments uh, like synthetic biology that are being led outside the DoD, and then our job is to really say what do these externally developed opportunities mean for the Department of Defense? What are the barriers to it becoming real, the technology becoming real, and who's working to overcome those barriers? What does it mean for the DoD as far as improving or hurting our capability, and what does it mean for other countries? And do we need to put in hedge development programs, or do we need to evaluate other technologies to help create a more robust response to certain emerging threats? So all of this is used to provide context to our research and engineering community as they do development and as they build systems. And the assessment leads directly to policy recommendations on what the DoD should do in response to these given technology development areas. Some recent technical assessments we've done are on human performance modification, printed electronics, synthetic biology. We've done a quick look at additive manufacturing. And in the future, we're looking at autonomy, metamaterials, quantum magnetometry, and we have a silicon photonics assessment that's also being kicked off. And what do these assessments produce? They produce specific recommendations on how to respond to each of these topics. So, for example, do we need to make investments to lead development? Do we need to make workforce changes to bring in skill sets to actually use new technologies that we may not have those skills in place right now? Or do we need to make infrastructure improvements to get the lab equipment in place so we can develop and have a government understanding of the new technologies when they come in? We're also very open to suggestions for new technologies. I'm a fan of crowdsourcing, and I think some of our topics, one of the best ways to do horizon scanning is just ask people what they think is going to be an emerging tech issue, and we can add those into our assessments as well. So the assessments are meant to inform strategy, make investment decisions, and then support individual activities. And these come not only out of the assessments, but out of our entire integrated framework from our work with the IC as to what the world is today, as well as to our predictions of emerging technologies and our assessments to make these very clear and distinct recommendations on what we need to do to respond. I think a lot of futurists talk about the world is going to be, a very cool place, and everyone agrees the world is a cool place today and probably going to be even awesomer tomorrow. But that's not as helpful as saying how do we what do we need to do to be able to react and be in a good position to use the day of tomorrow. So that's what we really try to inform. We don't want to just file reports up on a shelf. We want to make sure that people can use our recommendations that come out. I have an awesome team that works with me. Everybody is just top notch, from our technical librarian to our lead for assessments. our emerging technology consultant, Colby, is just an amazing asset to have on board. Everybody is fantastic and works very hard to make sure that we get our office working together. They're all very receptive, so if you want to reach out to anybody with specific questions, please do. The only caveat is Chuck, our intelligence liaison, is actually we're going to be moving on at the end of the month, so he may be less responsive than some of the others who will be around. And then finally, I wanted to conclude by saying if this stuff is interesting and you want to learn more about our products and where you can see what our office is doing, the bulletin is available at the link there. Like I said, anyone can subscribe. It's not a .mil. It's not a CAT card restricted. Soon we'll be moving that onto a website platform, which will make it a little bit easier and more interactive than what we have right now. It's a PDF attachment to an email. Everything's tagged, and unfortunately the tags don't do much on a PDF. It's just a nice word. But when we get into the website, you'll be able to look at back issues and see trends within a given tag over time, which I think is going to be very, very useful for folks. We also have an Intelpedia website where we put a lot of our information up, where you can see what our office is up to. We also have the DoD Techpedia, powered by DTech. So the DTech hosts this, and this I think is CAC enabled, but you may be able to get a username password for it. In Tech Space is another DTech product where we try and keep people aware of what our office is doing. There are some weekly topics we put out there and try and crowdsource information on what's going on. And then finally, we've just developed a WordPress blog that looks at general S&T forecasting events. This is we found that there's a growing number of people in the government and outside government looking at S&T forecasting, but there isn't a great resource for people to just check and find out. So we're actually putting on there events that would be useful to the community and actively looking for people who may be interested in contributing to the page. And as you hear about other forecasting events or interesting articles, feel free to let us know, and we will put it there, and hopefully that will become the central point for people interested in forecasting in the government and beyond in the S&T realm. So that's an overview of what we do, what we hope to do in our office, why we exist, and the goals of our product. So I'll leave this on in case you didn't have a chance to write down our contact information. There it is, and be happy to take any questions people may have.
Thank you very much. One question that I had, we had the ARL Chief Scientist, Dr. Lee, Stephen Lee, is working with the International Technology Centers. And we had a visitor last week. We had Navy Dahlgren in here talking about their bibliometrics analysis tool. So from our perspective, we'd like to learn what the other military labs are doing. And since Dahlgren just produced an EU Horizon scan, a study on energetic materials, we would like to perhaps not duplicate that effort. We ended up tasking NGIC to do a horizon scan for us, possibly on Asia Pacific, and maybe a topical study. And we haven't picked a particular area to do a topical study, but from seeing what you're doing, we don't want to do metamaterials if you're going to already do that one. So do you have some topics that you might suggest to us, or how we might coordinate this?
So this is also pretty interesting. So there's the typical areas are that you hear thrown around quite a bit are broad, huge areas. For example, within additive manufacturing, there's polymers, there's metals, there's different types of how you put down each of the materials. There are people who are looking at getting to a point where you can make structural components. There's multi-material, and each of those has their own set of technical challenges and their own set of implications. So in metamaterials, the first thing we have to do for all of our assessments is really scope down what is the thing we're going to look at, because it would be literally impossible to review all of metamaterials in all of the application space. So our specific technology assessment area is looking at metamaterials for RF antennas. Is specifically what we're looking at. And some of the implications would be like conformal antennas onto aircraft structures or ship structures. So wideband RF antennas using metamaterials. So there are clearly other areas of metamaterials that would be helpful and outside the scope of that assessment.
Certainly. And could you also explain the study on autonomy that you have on your list?
Right. So autonomy is another one that I've heard it used to describe almost like system process control. So if you can get the human out of industrial process system and just make all the monitoring and execution of a system autonomous, that being described as autonomy. The way we've scoped down our autonomy study is looking at autonomous vehicles, but used in conjunction with a manned vehicle. So you can think of it as either capability dispersion. So how would you take a platform with all its various systems on today and disaggregate it onto multiple platforms, one of which would be human controlled, and then the other ones would act autonomously based off of what the human control vehicle is doing. So it's more of an augmentation. It's not 100% autonomous, but I think this is one of the first steps that will be moving forward for autonomy. Before we just send ships off to do their own thing, even if it's just logistics mobility, before you have a semi go down from coast to coast driving itself, you'd probably have it follow another human first. So that's how we got picked into that that particular space of human augmentation. Pardon me.
Well, I'd love to hear if you have some ideas on how we can coordinate this. We want to make sure that we're leveraging what others are doing and not duplicating efforts. Could you speak a little bit more about the prototype and when that might be able to be tested or tried?
Yeah, so the prototype, it was, so the software development was complete last June. And we've been working through a lot of issues, getting it hosted so that other people outside users can use it. Right. So that's been more of a challenge than we anticipated. But right now we're down. We're being told a couple weeks from now it should be up and running for beta testers, and we already have our beta testers identified. So if you would like, we may have a couple open slots. So if anyone would be interested in beta testing, let me know. We can potentially add you to the list. Our list was developed a while ago, so it may need some updating.
Well, yes, I believe ARL would be very interested in that.
Another thing I'd like to point out is we're going to be sponsoring a research effort with Rick Tara out at AFOSR on that theory of emergence and trying to get a better understanding of how technologies go through emergence and what are some of those leading indicators. So that we're going to be actively building out the capability that's going to feed into the objective system. So how do we move beyond prototype system into a more robust tech watch price and scanning capability? Well, the first part is to understand the science. So with InfoSAR's help, we're moving down that path right now. That's been a really good relationship we've built. We had initially, but really the Library of Congress event really helped reinforce that relationship. So that was a good outcome.
Yes, it was certainly great for us because we weren't aware. Rick, you do have the microphone.
Oh, so I see a question from Brenda there. So they're not a coordinated IC product in the sense that IC products go through their formal coordination and review. We do use intelligence estimates of where technologies are globally as part of the input. And when we write an assessment, it's kept at the appropriate classification level. And then the final products, we go back through and change them where we remove the content that would be at a higher classification level, but keep the recommendations that are FOUO unclassified in there, but it loses some of the supporting documentation of why we make the recommendations. But even the classified versions are available to folks with the right access. So we think that's a much better approach than working at the unclassified level, making conclusions based on only the open source data, and then trying to get supporting intelligence at higher classifications that may actually indicate a different policy recommendation is more appropriate. So that's why we do it that way, where we start at the higher classification level and then work it down to get wider disseminations. So the assessments are not found out. They're not posted anywhere right now because they are FOUO, but they are available if you contact us over email. We'll be able to get them. If you are interested in some of the upcoming assessments, we do maintain an initial distribution list for each of the assessments. So if you are particularly interested in metamaterials or autonomy or silicon photonics, you can also let us know, and we will add you onto the list. So as soon as it goes out, you will be on the initial distribution list for the assessments.
That is good news. I'm thinking that, Brian, you gave us a lot of food for thought here, as well as a lot of paths forward to be able to find more information. I know that Joshua is trying to get in, perhaps ask us a question, but from our purposes, we should be following your websites, your distribution lists out of OTI, perhaps what AFOSR is doing as far as refining and continuing the conversation.
Yep.
And are there any other tips for us?
No, I think if you ever need to reach out to us, you can always email. So if you sign up for the bulletin here, there's an email link that comes. It's an office email that the distribution comes from, and you can email that, and it goes to the entire team. So that's another way to reach us quickly.
Wonderful. With your permission, will go ahead and widely disseminate this particular recording so that we can spread the word, as you've been kind enough to start introducing us to some of the work that's being done and sort of bringing that Intel community analysis and expertise forward. We really appreciate it. Thank you for your time, sir.
Oh, thank you. This is a great venue, and I really like the idea of getting the community together because there's a lot of work, and it's definitely growing. I think one of the emerging areas is tech forecasting, So someday maybe we'll do a forecast on forecasting. So this is fantastic. Really like that. Oh, real quick, I see the question about the NSWC guys. So the BAT tool is available for anyone in the government to use. I think that I'm not sure the specific limitations that they're talking about. I do know that you need to provide your own data, so you need your own data source. There's some data that comes in it. And in the indexing of the data so that it runs within BAT can be a little bit complicated. But I think so. I think the limitations are technical more than they are policy driven or restrictions. And the technical challenges I think we can work through. Those guys are exceptionally responsive, and if you work with them, I think they'll be able to help you get through some of those challenges, unless there are some different ones that I'm not aware of.
Well, I'm speaking for Joshua, and I don't want to steal your thunder, Joshua. Please clarify if you'd like to type into the chat box again. But it's my understanding that by us working and partnering with NGIC, we do have access to tons more data than we would normally have, than we currently subscribe to and pay for. So for the BAT tools purposes, we do have to be tied in to the IC in order to run most of these particular analyses. And I'm just wondering, does your prototype get around that, or does it not?
So for our prototype, we actually had to buy a license because we are not part of the IC. We couldn't ride the IC license structure, so we purchased our own. Data agreement through Elsevier for the prototype analysis.
Wonderful. Well, thank you, sir.
Thank you very much. Please reach out and contact me if anyone has questions that they might have been a little bit too bashful to ask right here.
I'm sure they will. Thank you.
All right. Have a great day.